For abstract, in order to create innovative engineering composite, civil construction waste have been mixed into polymer, surface modified with oleic acid AGC or geopolymer concrete waste GCW particle were combined with recycled polypropylene RPP matrix in the current study to create environmentally friendly composite. To effectively disperse the various ingredients, GCW particle and polymer powder were combined and reactive extrusion was used first to create the composite, and injection molding came afterward. These innovative composites were tested for tensile strength statistical analysis using ANOVA and water absorption accordance with ASTM standard. They contain 20%, 40% and 50% weight percent GCW particle and were both plane as received and surface modified. Atomic force microscopy demonstrated surface dispersion of nanoparticle, and scanning electron microscopy (SEM) was used for microstructure investigation. According to the finding, these environmentally friendly GCW particles that were added to the RPP matrix exhibit improved processability and water absorption rates of less than 0.01%. Compared to the pure RPP, which has a 529 megapascal elastic modulus, the RPP or AGC composite exhibits a substantially higher elastic modulus of 629 megapascal. This characteristic point to potential sustainable use for building construction utilize waste resources.
For introduction, traditional building material including wood, polymer, concentrate and metal are being replaced by newer and more environmental friendly options. Polymer material composite in particular material because of their inherent low density and suppleness. Reinforced composite are among the most popular building material in use today according to a new report. As a result of their inherent proposition, geopolymer have received attention because of their fire-resistant, high toughness and decreased CO2 emission throughout the production cycle. It is also possible to include geopolymer into composite material. Last but not least, the use of geopolymer fillet in hybrid composites was studied by Ferrer et al.
So I will present part which is flowchart in this GC for this article. For the first step, GCE will crush into smaller 270 mesh and with treatment for 24 hours for the temperature. This method will use 180 and until 200 degrees Celsius. In this state, water absorption will be happen and tensile quality will ascends. This action can be attributed to the hybrid filler. This method percentage of water will add the RPP/GCW and RPP AGC. On universal type in level 85 instrument machine, tensile test is accordance with ASTM D638 we perform. Finally, statistical validation of the properties obtained from 10 tensile testing specimens of each type of composite. That's all for me. Thank you.
For the type of material, for the first, plain geopolymer concrete waste GCW supplied by Lafarge Concreto LDTA from the Brazil. For the second, recycled polypropylene RPPP supplied by Commercial Brasilia DE Dediglam LDTA. For the third, oleic acid 99% of by purity was supplied by Sigma Aldrich Brazil. For the last, recycled PP composite incorporate with both plain as received GCW particles and oleic acid surface that modified AGC for the particle were evaluated.
Part is about results. So for finger 1, the elastic modulus increased significantly over 20% integration of oleic acid surface. Treat the geopolymer concentrate the waste. And then this translates to a significant increase in the stiffness of RPP or AGC composite density on the other hand, but for figure 1C, AGC incorporation caused a reduction. The product of crack, as detailed further in the section on microstructural evolution, may be the cause of this negative consequence in strength and deformation. After that, for table 3, present the value of the ANOVA parameter F critical is FC and P. In this table, also considering that 5%, which is a score 0.05, is the level of significant value of LC associated with 95% of confidence in the difference between them. Moreover, if P over than 0.5, a significant difference might be considered between value. Based on the ANOVA also, the incorporation of modified AGC into RPP caused a statistically significant increase in the elastic modulus, and the hypothesis that the values are the same can be rejected with 95% of confidence. For figure 2 also showed CEM photography of 20, 40 and 50% AGC incorporated into the RPP composite. Each on in both processing condition if energy is reduced. Then for figure 2, B, D and F, the inventory extruded condition reveal a fracture is associated with more pore than finally injects. This clearly indicated that the second step, if injection process has significantly decreased than porosity mainly of 50%. Finally, for figure 3, despite AFM finding for two extreme conditions of RPP composite with 20 and 50% AGC, this image despite the shift in roundness from a reasonably smooth surface for the 20% AGC composite in figure 3A to a higher surface. And lastly, the result in figure 3 show how AGC particles have a considerable impact on the composite surface topography as previously discussed. The result in figure 2 for the 50% AGC composite show an efficient encapsulating states which should be read as satisfactory particle RPP metric in the Hessian. That's all for me. Thank you.
So in conclusion, recycled polypropylene RPP matrix combined with 20%, 40% and 50% geopolymer concrete waste particle, both plain as received GCW and onion acid surface treated HGC was first processed and evaluated. After an initial extrusion and an injection molding process, RPP AGC composite have better molding and less extrusion torque than RPP GCW composite. For both RPP GCW and RPP AGC composite, even pure RPP had a water absorption rate of less than 0.01%. So when there are more than 20% of AGC particle in the RPP matrix, the elasticity of the RPP matrix goes up a lot. So if you use a composite with a lot of AGC, the particle will stick together and make the surface more rougher. This can be used to make the material more stiffer. Thank you.